Hello everyone. In this video we're going to go over lessons 13C, D, and E for our class of March 8 of 2024. So the initial setup has a context where we have a video camera mounted on a remote control robot that is located 1,000 meters distant from the launching pad. So that gives me, let me see if I can create a diagram here. That creates a right triangle situation where I have the camera located here, and of course the rocket launching from the ground. So I have some situations like this. So again, here's going to be the rocket. And this is a distance d from the ground, or the height. This is in the angle of elevation from the camera, that is here. And there's a distance here between the launching pad and the camera of 1,000 meters. So the first thing that we want to do is draw this diagram. And of course, once that we draw this diagram, we want to write an expression of d as a function of theta. So in here, notice that this is the right triangle as usual, and we have the d's representing the opposite. So if this is the hypotenuse of our triangle, we can make a relationship between the sine of theta and that's going to include only the opposite and the hypotenuse. Since we don't have the value of the hypotenuse, maybe we shouldn't use the sine. So instead, this produces the need to use the values that we know, which are d and 1,000, or at least the height in 1,000 meters, which is some of the values that I can know. So we have the tangent of theta instead, being the opposite over the adjacent. So this produces this relationship. And we can then say, well, then d can be modeled as 1,000 tangent of theta. Okay. Now, part C says, in the previous assignment, you work with the inverse tangent. So can we write, instead of d in terms of theta, can we write theta in terms of d? And that happens when we flip around things. So we can say, well, tangent of theta is going to be d over 1,000 again, and then here theta is going to be tangent to the minus 1 of d over 1,000. And that is itself the setup of this. Now, the rest of this lesson is about checking what happens when we have certain heights. So part D says the robot can receive real-time data on the altitude of the rocket and can use the data to set the appropriate angle to keep the rocket in view. When the rocket is 100 meters above the ground, what should the angle theta be in radians? So because this 800 meters above the ground is the d, then we can just replace that d by 100, and so we will get tangent to the minus 1 of 800 over 1,000. Using the calculator, we're going to get that this is 0.67 radians. Now, thanks to this function that we found here, we can create a graph of that. And there's multiple ways that you can do this. Of course, this needs to have into account that we're exploring not particularly the tangent function by itself, but we're exploring a function that is in terms of the height that we have, and also the inverse function. So we're really going here for we're going here for the tangent to the -1 function that we can create here. Now the problem with this is that it's not something that is very easy to see, and we gotta create a labeling where we're inputting the distance, and what we get is the angle. So of course this is going to provide us with things like 0, 0.5, 1, and the maximum that we can get is going to be 1.5, since it's close to 1.6, which is pi over 2, which is like kind of the boundary of what this is going to be for tangent to the -1. So we can take distances, 2,000, 4,000, 6,000, 8,000 of distance, and 10,000 at the end. And you're going to see some movement like this, where the function is increasing, but it's not going to go further than 1.5. So that's the point of graphing data in terms of d. Now, for part B, we want to see how things are changing. So the rocket is traveling from the ground level from 2,000 meters, and we want to know how the angle of the camera is changing as it moves from 2,000 meters to 4,000 meters. So for that, we gotta go back again to the function that describes theta. And so theta here is tangent to the -1, and we gotta calculate what happens in 2,000, and of course we also gotta calculate what happens on 4,000. And in 2,000 is going to be 1.11 radians, and then what we can do is also check what's going to happen when we're going on 4,000. And then calculate the difference of those two. So when we're in 4,000, this is around 1.33. Now, because we want to check the difference, then we do the difference between those two. We can call this theta 1 and theta 2, and the difference between theta 2 and theta 1 is just going to be approximately 0.22 radians. So you can say that the change on this amount is being 0.22 radians. Now, same thing happens here when we compute on the 1,000,000 meters. And this is just to find out that the boundary, of course, is going to be what we expect, and is going to be pi half. So this result that we're going to get here should be really, really close to 1.56, since this is the value of pi half. Notice that this is actually 1.56. And notice that pi over 2 can be approximated to 1.57. So this would be like, if we think about the camera following the rocket, this will be almost when it's horizontal. So that's like the maximum possible that it's gonna get, but it should never get to that, because we will not have a triangle in that case. All right, finally, we have, to conclude this, we have another scenario where we can use this tangent to the -1. We have a rough truth that is specified to have a total width of 50 feet and height of 10 feet. We want to know what must be the angle on each of the sides of the truss here as is displayed to find out to find out the best angle here. So this is just the same scenario. Notice that we have here right triangle where the opposite is 10 feet, and of course, because this is measuring 50 feet in total, then each of these sides should be only 25. And if we're considering one of these triangles, then I can check the angle by doing tangent to the -1 of 25 over 10. And so this is going to give me like 21.8 on degrees. So all in all, the purpose of this lesson is really to help you identify some of the things that make part of the tangent to the -1. Understand that the inverse tangent function can help you find an angle, but of course that it has a limitation when we're reaching pi half and minus pi half, because that's essentially the boundary of the domain of the tangent to the -1. Now on D, we're going to do something similar, but we're going to go towards the secant function.